Okay, derivative rules for a complex quotient. Now, I say quotient because that's the way I'm going to solve it. I didn't mean to draw a line through that. Okay? But you could have set this up as a product. I'm going to show you how you can set it up as a product. Then I'm going to solve it as a quotient. Kind of redundant, but whatever. So, they want us to find g prime x. Derive this function. Well, this function here can also be written as, and we'll move this down a little just so you guys can see this idea. This function g at x can also be written as 1 plus x squared to the power of 10 divided by 1 minus x squared to the power of 10. When it's written like that, that also means, I don't know why I wrote prime, just want to write another way of doing this here. This can also be written as 1 plus x squared to the power of 10 times 1 minus x squared to the power of what? Negative 10. This would then go into a product rule. We've already solved a question like that in a different lesson here. Okay? And this would be a complex product. But we're not going to solve it that way. We're going to solve it, okay, with our chain rule and our quotient rules. So we're going to go down a little. And instead of doing that, we're going to find g prime x. And in this case, think of it like this. We have our power of a function. Okay? So we're going to have to bring that power down. And we're going to have 10 multiplied by what's originally already in there, 1 plus x squared divided by 1 minus x squared, to the power of 9 now. Okay? And then I got to derive what's inside this function. Well, what's inside this function is a quotient. So we're going to use our quotient rules to solve that. If you don't remember a quotient rule, I'll quickly write it up here. That's f prime x times g at x minus f at x times g prime x divided by g at x squared. Okay? This is our quotient rule. So what that means, this now becomes, think of this part like our f at x, and this becomes our g at x on the bottom. So first thing we need to do is we need to find a derivative of that, 1 plus x squared, which is just going to be our 2x, multiplied by the original g at x, which is 1 minus x squared. And that's going to be subtracted by the original f at x, which is 1 plus x squared, times the derivative of the bottom, which will be negative 2x. Okay. All of this will be divided by what was on the bottom squared. So we have 1 minus x. And this is already squared. We're squaring it again. So essentially it's going to become to the power of 4. Now, this is technically it. If they've given you a value, okay, and they say find g prime x when x is equal to 3, that's it. You can just plug 3 into x right here. There is no need technically to simplify. They may ask you in a question to simplify though once you find the derivative. So we're going to go about trying to simplify this a little easier. Okay. So when we go to simplify this, what I'm going to do actually is I'm going to make this all one line. I'm going to try to make this all one line. First, we're actually going to look at the fraction on the top on the right. If you look at this, what I mean by all one line is this can be written as 1 plus x squared. Oh, sorry. I did write this part wrong. That x was the only thing that was squared. The brackets weren't squared. So now the brackets are squared. I apologize. Okay. This to the power of 9. And then I could technically write this as 1 minus x squared to the power of negative 9. Now we don't have to apply any product rules or anything like this, but this kind of gets rid of fractions, so maybe I'll be able to find some like terms a little easier when doing this. This may or may not help. We don't actually know yet, so let's go through it. Now I'm going to work with a second set of brackets. I'm going to try to simplify what's on top of that. In fact, what I'm going to do is I'm going to distribute the 2x and the negative 2x to both of these terms, and I'm going to distribute my negative. Don't forget that. So this is going to give me 2x minus 2x cubed This will be subtract the bracket, and then we'll just kind of take it all off in one step. Negative 2x minus 2x cubed. Okay? But because there's a negative on the outside, that's going to change both of these signs when I bring it to the inside. So we kind of get rid of that, and we move the question a little closer together. And that is above our straight line here. That's above our 1 minus x squared squared. Now if you take a look at this, negative 2x cubed, positive 2x cubed creates a 0, and 2x plus 2x is going to give us 4x. So we're multiplying by 4x divided by 1 minus x squared to the power of 2. Now I did bring this up here, but I've now noticed, okay, if you guys take a look at this, I've now noticed what we have. Where's my magic? Is I actually have a common denominator. If I bring that back down into a function, we have this here. The only difference is their powers are a little different. Okay? So because their powers are a little different, that's okay. We're still multiplying across here. We'll be able to multiply those. So I'm going to put that back into fraction form. I brought it up to see if it would help. After a second look at it, it probably won't be helpful. So I'm going to put it back into fraction form. So we still have 10 times 1 plus x squared to the power of 9 divided by 1 minus x squared to the power of negative 9. I know those aren't on the same level right now, so let's move it up a little. There we go. Oh yes, positive 9 at the bottom. Thank you. Sorry, when we move it back down, it's no longer negative, it's positive. Okay. Now we're multiplying across. Think of these bases. Okay. Think of this as if I said let 1 minus x squared be equal to y. What this would say is y9 times y2. Okay. Well, what is that going to give us? We just add the exponents, y11. So at the bottom, okay, instead of writing y, we just kind of did that on the side to make it simpler to look at. 1 minus x squared to the power of 11. And on the top, well, I'm just going to combine my 4x with 10. That will give me 40x. And we have 1 plus x squared to the power of 9. Now I realize the simplifying of this is probably the hardest part. And they may ask you to simplify on a test to get it to an easier form to work with. But if I've given you a specific number, remember you don't technically have to do that. Though it will be helpful if they've given you several points. If they ask you maybe for this equation, find the points tangent at 5, 6, 7, 8. Well, that's going to be a lot more complex to plug into this equation. It'll be a lot easier if we just find the simplified form and then plug in those values for x.